Hello and welcome back. In this video we will be talking about exponents, and to set up some of the language that I'll be using in this video throughout, I'm going to use a as the base and n as the exponent. So when I write an a with an n a little bit above it, I'll refer to this as a to the nth power. And there's a couple special cases. So a to the second power is also called a squared. And a to the third power is also called a cubed, but you can just say a to the third power or a cubed, a to the second power or a squared. It doesn't matter. They mean the same thing. And to explain what we mean by a to the nth power means n copies of a all multiplied together. And I think it's easiest to see some examples with numbers. So for instance, 3 squared, or 3 to the second power, is going to be 3 times 3, which we know is 9. And it's and there's not a whole lot more to it. So 3 times 3 is 9. 4 to the third power, this is going to be 4 times 4 times 4. And again, we can do this. 4 times 4 is going to be 64. 4 times 4 is going to be 16. Times 4 is 64. Also down here, 5 to the second power, so is going to be 5 times 5, which is 25. And then 2 to the 10th power, okay, so now we're getting into a lot of 2's. It'll be 2 times a bunch more 2's, and in fact, we know that we'll have 10 of these. And this is getting to the point where it would be a little bit easier just to use a calculator. So we can take 2 times itself 10 times. This is one that I've done beforehand, and this is going to be 1024. So you can see how when we take high powers, and when we have a big exponent, numbers get big pretty quickly. Here's a special case. 7 to the first power, that's just one copy of 7, which is just 7. So it turns out anything to the first power is always itself. So if I take a to the first power, it's just a. It doesn't matter what a is. 7 to the first power is 7. 12 to the first power is 12. Anything to the first power is just itself. So this is a nice easy one. So exponents aren't too hard. It's just going to be multiplication. There's a rather nice situation when we have multiple exponents on the same number. So here I have a to the nth power, and I'm taking all of this to the mth power. And before I give you the formula for what this equals, again, I want to show you this in terms of a number. So if I take 4 to the third power, and then raise that to the second power, again, we can break this down. Anything squared is it times itself. So this is going to be 4 to the third power times 4 to the third power. But 4 to the third power, that's just 3 4's being multiplied together. And 4 to the third power is another 3 4's being multiplied together. So I have 4 times 4 times 4 times 4 times 4 times 4. And overall, what is this? Well, 4 times 4 times 4 times 4 times 4 times 4. That's just 6 4's. So this is just 4 to the 6th power. And I can actually get from here to here in one step because of this rule. So again, 4 to the third power to the second power. I have 2 copies of 4 to the third power. Each copy has 3 copies of 4. So overall, it's 4 to the 6th power. So when I simplify this, this is going to be a to the n times mth power. So we get to multiply the exponents together. And then we could use the same rules as before to come up with this. So I believe, I had done this calculation just a second ago. I believe this is 4,960. So for instance, down here, if I have 5 to the second power to the second power, I can rewrite this using my rule, since I have an exponent and another exponent. This is going to be 5 to the 2 times 2 power, which is 5 to the 4th power. So then this will be 4 copies of 5, so 5 times 5 is 25, times another 5 is 125, times another 5 is going to be 625. So again, this is just something you can do with a calculator. 2 to the 3rd power to the 4th power, this is going to be 2 to the 3 times 4th power, which is 2 to the 12th power, and again, this is going to be 4,096. Again, I did this beforehand with a calculator, and you'll notice that we can get to the same number in multiple ways. And then this last one, 10 to the 2nd power to the 6th power, this is going to be 10 to the 2 times 6 power, which is 10 to the 12th power. And it's nice multiplying tens together because it's just going to be a 1 followed by that many zeros. So 10 to the 12th power is a 1 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12th power. And this is, we can count off, so this will be 1,000, million, billion, trillion. So this is 1 trillion. But again, multiplying by tens isn't that hard. We just need to know how many tens to multiply. With an exponent raised to another exponent, we multiply the exponents together. The last thing to really talk about with exponents are when exponents are going to be fractions. And to start with, I want to give you some motivation for why we might consider fractions as exponents as opposed to just numbers. So here I have an equation. A to the 3rd power is equal to 8. My question is, what is A? So A here, A to the 3rd power is equal to 8. That means that if I take A times A times A, I'm going to get 8. And when I look at this, if I think about this carefully, I can see that, oh, if I happen to take 2 times 2 times 2, well, that's 8. And it turns out that there's only one solution to this. A is just equal to 2. So this I got because I just happen to know that 2 times 2 times 2 is 8. But there is a more mathematical way to arrive at this. So let's start over. Let's say that I have A to the 3rd power is equal to 8. What I want to do is just get an A. I don't want A to the 3rd power, I just want A. So how do I get rid of this 3rd power up here? Well, I'm not adding 3, I'm not multiplying by 3, so I can undo addition by subtraction, I can undo multiplying by dividing. How do I undo raising something to the 3rd power? I'm going to use the rule that we just learned. If you raise an exponent to another exponent, we multiply. So what could I possibly raise this to get rid of the 3? And the answer is, if I raise it to 1/3, so whatever I do to one side, I have to do to the other. So now I have A to the 3rd power to the 1/3. And there's a reason I'm doing this. The reason is, if when I do this, I can simplify. So it's going to be A to the 3rd times 1/3. And over here I have 8 to the 1/3 power. Well, what is 3 times 1/3? These cancel, and I'm just left with A is equal to 8 to the 1/3 power. And this is all I need. A is equal to 8 to the 1/3 power. So now the question is, how do I take something to the 1/3 power? And again, up here, I know that this is 2 because 2 times 2 times 2 is 8. So if I take 3 copies of 2, multiply them together, I get 8. So what happens if it's a number that's not so nice? What happens if it's a number that I don't know that this is here? Well, luckily we can use a calculator to be able to solve this. So I'm going to show you a calculator, an online calculator called Desmos. Maybe I can zoom in a little bit. So now it should be full screen. I'll move myself up here. So if I want to take 8 to the 1/3 power, I can take 8. So I'll click 8 here. And then we have a to the b. So this will take whatever I type in next and type it in as the exponent. So a raised to the, and then I want 1 divided by 3. So if you look over here, I have 8 to the 1/3 power, and this tells me my answer, which is just going to be 2. So that's quite handy. So if I come back over here, after I type this into my calculator, I get that this is 2. So let's look at this. Move myself back down to the corner. So a to the 1/n power is the nth root of a. So this is how we refer to this, the nth root of a. And it's the number such that if you take it times itself n times, you get a. So let's do this guy in multiple ways. So 36 to the 1/2 power. So again, I'm looking for the number that when we multiply it by itself twice, we get 36. Well, you and I both know that 6 times 6 is 36. Oops. So we know that 6 squared is 36. So 6 is going to be 36 to the 1/2 power. And let's check with our calculator. So let's clear all. And if I take 36, oops, let's use my mouse, and I raise it to the 1 divided by 2, so 1/2 power, I get exactly 6, which is what I said. Let's do a couple of more examples. So here I have 80 is equal to a to the 4th power. So I want to know what times itself 4 times is 80. So again, if I want to get a by itself, what I can do is I can take both sides and raise it to the 1/4 power. So instead of having a to the 4th is equal to 80, I will take both sides and raise it to the 1/4 power. A to the 4th to the 1/4, well, 4 times a 4th, that's just 1, these cancel. So a is just 80 to the 1/4 power, and I can plug this in to my calculator. So let's clear all. I take 80 raised to the 1 divided by 4, and I get this monstrous beast over here, 2.990697562. Quite often these numbers are going to go forever, and it would be impossible to write down all of the decimal places. This is only showing 9 places after the decimal. This actually goes on forever. So what we'll do normally is we would round to 2 decimal places. So I'll just use the first 2 decimal places, and we'll notice that we don't round this up. So this is just going to be 2.99. So let's go back here. So according to our calculator, this is going to be approximately, so I'll use squiggly equal sign, it's going to be approximately 2.99. And let's do one more. So again, I have a to the 3rd is equal to 57, but I don't want the 3rd there. How do I get rid of it? I take it to the 1/3 power, and to the 3rd power and the 1/3 power, these cancel, so I'm left with a is 57 to the 1/3 power. And I don't know what that is, so I'll type that into my calculator. So I'll have 57 raised to the 1 divided by 3 power, and over here I have my answer. Again, I will round to 2 decimal places, and I will need to round up because of the 8, so I get 3.85. and that is how you take the nth root of a number.